Hello everyone, I am Khadargo Sonur. I am presenting our project Credit Card Fraud Detection using Machine Learning. These all are my team members. Now let's see the introduction. So the credit card fraud is a serious problem nowadays which is affecting the financial institution as well as the customers over all the world. So it involves unauthorized use of credit card for purchases or the cash advances. So it mainly happens when someone tries to buy some things or cash delivery without the permission. So to detect these fraudulent transactions, we make use of the machine learning models, which will analyze the transaction patterns and identify these anomalies in a quick amount of time. Thank you.
These are the objectives of our credit card fraud detection. In this, the main goal is this project is built a machine learning system that can automatically detect if credit card transaction is fraud. It means the credit card fake or unauthorized or legitimate, real or authorized. In this, what will we do? First, work with the real world data. In this, use a real credit card transaction data set. This data set contains thousands of past transactions, some of which are fraudulent. Each transaction has different features, such as the transaction amount, time, and other hidden features. The process of the data in this is clean the data. In this, we remove any errors or missing values. Next is to balance the data. Uh, how we balance the data means fraud cases are rare, so we may need to adjust the data to train the model better. And next, we normalize our scale features so all values are on similar scale. Next, we train machine learning models. In this, we use to such a models that is logistic regression. In this, a simple model good for binary classification. It means that is fraud or not fraud. In this, next algorithm is random forest, a more powerful model that use many decision tree to improve accuracy. Next, we split the data into training set and testing set. In training set, to teach the model, and testing set to check the how well it works. Um, Next, we evaluate the performance. In this, we will measure how well the models work using first, that is accuracy. In this, how many prediction are correct. Next is precision. In this, out of all times the model said fraud, how many were actually fraud. Next is recall. Out of the actual fraud, how many the model was able to detect. F1 score means it balance between precision and recall. Mm, the matrix help to understand if the model is good at detecting fraud without too many false alarms. Next, we build an alert system. In this, we develop a simple system or a program that takes a new transaction and uses the trained model to predict if it is fraudulent. Next is sends an alert, like a message or warning, if it thinks the transaction is likely fraud. Uh, the main reason why this project is important means credit card fraud detection is serious issue that costs billions of dollars in worldwide. A good detection system helps to protect people and business from financial losses. This project shows how machine learning can solve real life problems.
Hello everyone, my name is Mohammad Anas. I am today explain about methodology. We use the following steps to build the project. Data collection. We use a public data set from Kaggle containing credit card transaction uh, European data card holders. The data is anonymous for privacy. Second one is data pre-processing. Handle 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 a class imbalance using oversampling. normalize features, split data into training and testing sets. Here, the class imbalance handling fraud detection data sets are usually imbalanced. So, we use smooth synthetic minority over sampling technique to balance them. And third one is normalization features. Normalization features, we scale features to bring them to the same range. And data splitting, the data set is divided into training and testing sets. Third one is model building. We train and compare different classifications models like logistic regression, decision tree, and random forest. Next, boost. Fourth one is evaluation. We evaluate the model performance using classification metrics like accuracy, precision, recall, F1 score, etc. Deployment optional. If needed, we can create a simple web app using Streamlight or Flask to show the prediction bonus part. Flow diagram. Here the flow diagram is summarized. Enter the process 5 main steps. First one is data collection. Get the data set from Kaggle. Second, data pre-processing. Clean, balance, and prepare the data. Third one, model training. Model training is a training in machine learning models using proceed to data. Fourth one is model evaluation. Assess the model performance using matrix. Uh, Fifth one is a prediction. Use the best model to predict the fraud. Thank you.
Hello, good evening. I am Mohammed Junaid. Now we are going to explain the applications. First is fraud detection in banks and systems that identify suspicious activities like stolen cards, identify theft or a usual account behavior using data analysis and machine learning. Now, next is the real-time alert system for unusual transactions. That is, it monitors the transactions lively and sends instant alerts to users or a security team when a suspicious transaction is detected. Next is risk assessment system for online payment platforms, where it assigns a risk score to every transaction based on factors like location, amount, and behavior. And high risk transactions may be blocked or flagged for a review. Next is insurance claim fraud analysis. That is, it detects the false or inflated insurance claims that using a data patterns. Usually, it helps to reduce the losses by flagging suspicious claims for investigation. Next, before coming to the conclusion, we'll explain the part of a code.
So here we are importing the required libraries like import pandas as PD. Here the pandas is used for data manipulation and analysis. And next importing the NumPy, which is used for the numerical operations, especially arrays and the matrices. Next we are importing the matplotlib.pyplot, which is used for the creating statistic visualization. For example, like bar plots and histograms. Next, we are importing the Seaborn as SNS, which is a statistical data visualization library, which is built on the top of the Matplotlib. Next, from the scikit-learn, we are importing the train test split, which splits the dataset into training and the testing sets for the model evaluation. Next, from the scikit-learn, we are importing the decision tree classifier as well as the plot tree. Here, the decision tree classifier is the algorithm used for the classification task, and the plot tree is used to visualize the decision tree structure. Next, from the scikit-learn, we are importing the classification report as well as the confusion matrix. So, the classification report provides the precision, recall, and the F1 score, and the confusion matrix shows how well the model is predicting each of the classes. Next, from IMB learn dot over sampling import SMOT. Here the SMOT is a synthetic minority oversampling technique which is used to deal with imbalanced datasets by generating synthetic samples for the minority class. Especially in these fraud cases, next we are loading the dataset. Here it reads the CSV file containing the credit card transaction into a data frame DF. Then the data set typically has the features like time, amount, and 28 anonymized V1 to V28 features, and a class label where 0 is the normal transaction and 1 is the fraudulent transaction. Next, we are displaying the data set by printing DF. Next, we are checking the class distribution. That is original class distribution df class dot value counts. Here it prints how many samples are in classes R. For example, 0, 28,000, 28, 4315, and those are the normal transactions, and here 492 are the fraudulent cases. Thank you.
Next is the line df dot drop now. The subset is equal to class in place is equal to true. It removes any rows from the data set where the target label class is missing. Next x is equal to df dot drop class comma axis is equal to 1. It separates the input features that is independent variables by dropping the class in columns. Next y is equal to df class. It assigns the target variable that is fraud or not to y. In most credit card fraud data set, fraudulent transactions are very rare compared to normal ones. This creates class imbalance which can make models biased towards predicting not non-fraud. SMOT, it is a synthetic minority over sampling technique. It is used to create a synthetic artificial example of the minority classes that is fraud cases to balance the data set. Next is x underscore s resampled and y underscore resampled is equal to sm dot fit resample x comma y. It applies the SMOT to generate a new balanced data set with an equal number of fraud and non-fraud examples. This helps the machine learning model to learn better and detect fraud more actually. Thank you.
Here the next is splitting the data set. Splits the data set x resampled y resampled into training 70% and training 70% and testing 30% sets. X10 and Y train used to train the model, and X test Y and Y test is test the model performance, and random state is equals to 42 ensures the reproducibility. Same split every time you run it. Output is a no. Here the initialize the decision tree. Initialize the decision tree. Create a decision tree classifier with Certanian entropy uses information gain to decide splits. Max depth is equals to 5. Limit free to a depth to 5 to prevent a overfitting. Random state is equals to 42. Ensures the consistent result. Next, predict on test sets. The train the data, train the mod, the train the model, and trains the decision tree on the training data. X10 and Y train. Here the data model learns patterns from the training data sets. It make the prediction y pred is equals to dt model predict to x test Explanation predicts the fraud or not, usually 0 for non-fraud 1 and fraud for test data X test. Y stores predict labels. Its example output is 11011. This is the sample of actual output depends on the data. Thank you.
Hello once again. Now we'll explain the next part of the code. Here we'll print the classification report. It evaluates how well your model is performing, and what it shows it shows that the metrics like precision, recall, F1 score, and support for each class, that is legit or fraud. The useful is to understand how accurately the model detects fraud and avoids the false positive. That is here precision and recall. You can see that the precision is 0.96 and recall is 0.98. That it predicts the up to 96% and 98%. And next here will comes to the confusion matrix, where it shows how many correct and incorrect predictions our model has made. That is, rows is actual classes and columns will be the predicted classes. Now, for example, if we take the true positive, that is legit, predict as legit, and bottom right, true negative, fraud predicted as fraud. Heat map makes it a easy to visualize performance. Here is our the confusion matrix, and next we will come to the plot about the decision tree. Here it visualizes the structure of the trained decision tree, and it shows how the model splits the data based on the features to decide whether a transaction is legit or a fraud. It helps to understand how the model makes decisions and which features are more important. See, this is our decision tree. Now we will come to conclusion. So here we can say that credit card fraud detection is a very serious crime, and due to technologies, high-based technologies, credit card fraud, it has become more, and in detections with will help with the machine learning helps spot suspicious transactions quickly, and by cleaning the data using a good model, we can accurately detect the fraud and keep the customer payments safe. Thank you.